So this is part 2.5, which is going to be about the Pauli exclusion principle and also energy diagrams and Hund's rule. So we were talking about quantum numbers before, N, L, M, P, Ms, which are the numbers that describe what configuration each electron is in. The exclusion principle, or Pauli exclusion principle, named after Pauli, who is a famous physicist worked in quantum theory, is pretty simple. No two electrons can have exactly the same quantum number in the same atom. So for example, here we have helium, which has a 1s with two electrons in it, one spin up, one spin down. So they have the n equal 1, L equal to 0, M equal to 0, and you guessed it, S equals plus or minus a half. This would be 1/2, this would be minus 1/2. So those are the spins for the two electrons. However, each orbital configuration can't take more than two electrons. So basically that's what the exclusion principle is saying. When you want to move on to lithium, which has 3 electrons, one has to go up into 2s orbital, as opposed to adding one down into 1s. So the Pauli exclusion principle, pretty easy to get your head around. You can only have 2 atoms in each electron configuration, in each orbital, one spin up, one spin down. So you can't have two. What's probably important to note is you also can't have 2 atoms that spin up, because that means they have the same quantum number, because S would be, for both would be half, so that's not allowed either. So that comes in to play when we're talking about doing energy diagrams and Hund's rule. So for example, here's an energy diagram for carbon. Carbon has 6 protons and 6 electrons, so its 1s is full, one spin up, one spin down, 2s is full, one spin up, one spin down, and the 2p has 2 electrons in it, one in 2px and one in 2py. And you, in energy diagrams, you can draw this like the electrons on a line for each energy level corresponding to 1s, 2s, and 2p, x, y, and z. The reason why these are spin up as opposed to one spin up and then one in here, which is not the case, is because of what's called Hund's rule. And Hund's rule states that the lowest energy state is the one with the largest number of unpaired electron spins. So in this case, where there's 3 electrons in, say, a 2p orbital, the lowest energy state, they will fill up like this. So there's 3 unpaired electron spins all spin up, and this state where you've got a paired electron spin, so a spin up and spin down in the same orbital configuration, that is actually a higher energy state. So that's all that Hund's rule is saying. That's why carbon actually behaves like this, and that becomes important when you're talking about carbon-carbon bonding and orbital hybridization. So yeah.